Hello and welcome. Thank you for joining me in this review. This is my AWS Cloud Resume page and it's up and running. And this is just meant to discuss or explain how I have built the project and then how it actually functions. So why I've built the project actually, first, I'm new in the cloud DevOps space, and then this is to put my learning to practice because you learn by doing. And then bringing different AWS services together to work a solution, and I'm happy with these outputs for now, right? And I'm actually also doing the video just to probably show my documentation skills and ability to also explain my project, what I've done, and probably the rationale behind using these services or using these tools, or why not doing the opposite. Okay, and and also maybe perhaps people that are in the same category or people that are just about to start can also be encouraged by if they see this and also learn from it. All right, so thank you once again for joining me in this review. So my resume page is running, and first I'm going to run through the infrastructure breakdown. So this is my architecture diagram for the project, and first, my project is hosted on S3, which is Amazon Simple Storage service, and then the front end also content is being served through the CloudFront, which is the Amazon Content Delivery Network. So what the CDN does is actually, what the CloudFront does is actually serving my content around the world and making sure that users can get them faster by caching contents. All right, so if someone from London has requested the site, it's going to be cached in the server close to London or inside London. And of course, if any other person is requesting it, if it has not been updated from the back end, that person can get a faster response, and of course, which I'm going to demonstrate very soon as well. So, but requests are actually blocked or allowed by AWS WAF, which I'm going to explain later. All right. So for the back end, it consists of API gateway, the Lambda, and then the DynamoDB. So if a new user visits the website, there's a JavaScript in the site, in the HTML document, that calls API gateway. So the REST API invokes Lambda, and Lambda actually checks the DynamoDB table and updates the count. It fetches the count that is there and updates it if it's a new user. If it's not a new user, it doesn't update the count. All right. And for test purposes, I have limited the time to just 2 to 3 minutes, such that even if I'm a new user and I reload the website, it's going to, within 2 minutes, after 2 minutes, it's going to count me as a new user. That's for test purposes. But in production, I've actually just increased the time to 12 hours. And one other thing I need to explain here is that, how do I recognize a new user? I tried different things. I tried session and cookies. I didn't work with those ones. For local storage, if I reload my website every minute or every second, it actually counts as a new user. I decided not to use that one, so I opted for the IP address. But of course, I'm not going to see these IP addresses, and I'm not storing them, but I just have their hashes. All right, and I can't recover them because it's a one-way hash. It's a one-way hash. So I can't get the hash. So the site actually sees IP addresses, unique IP addresses, as new users. Okay, so I explained earlier, WAF is protecting my requests, and of course, for monitoring, I have two CloudWatch alarms that are attached to one to the API, and the second one to the Lambda function that counts the visitor's website, that makes the counts. If there's an issue with these counts, with the Lambda function, with the code on my API, it sends an alert to an SNS, simple notification service, which of course forwards those responses or alerts to an email and forward to Slack workspace, and of course, such that if I miss email, so that I don't miss an urgent alert. So I actually added PagerDuty, which will send like a push notification live to my phone, of course, and probably an SMS is a text message to my phone as well. All right. So users actually have a custom domain through which they access my website. This is Route 53, and I've activated DNS security. This is just to make users confident that responses they are getting are from my backend and someone have not actually interfered with it. So that's DNS security. Okay, and the rationale behind using Lambda for PagerDuty. Yes, PagerDuty can actually subscribe straight to HTTP subscription, HTTPS to simple notification service. But I needed to store my integration URL, and I needed to store it in AWS Secrets Manager. And SNS cannot natively retrieve secrets from Secrets Manager, so I needed to use a Lambda to do that. And so Lambda retrieved the secrets and forward those messages to PagerDuty. Of course, I'm going to demonstrate that, and it also does the same for Slack. Lambda forwards to Slack. Slack cannot natively subscribe to SNS, and of course email can natively subscribe, so I don't need an intermediary, and this is why it does. This is coming. So all the deployment happens using Terraform. If I push to main on GitHub Actions kicks on, and then there's a code test which tests my Lambda counter code. Yes, my visitor Lambda code. If it passes, of course, and then the whole setup runs. If it doesn't pass, it's the workflow is going to fail, and I'm going to go and try to debug. But if it passes, the whole setup is deployed, and of course, there's also an end-to-end test that runs again to check if the website is actually running and if those things I want to appear there are actually appearing. So that is all about the architecture of yes, of my Cloud Resume page. So I go back to the page. As you can see, everything is working like I mentioned earlier. This is my logo, the logo AWS has given to me when I passed the Cloud Associate exam, and of course this is my validation of code to show that I actually passed the exam. Yeah. All right, so I'm just going to try some of the links, and of course, this is the simplest of things to do. My links are actually working, links to my GitHub page and to my blog, and yes, and to my LinkedIn page. They are all working. This is my LinkedIn resume, LinkedIn page. So they are working. I'm satisfied with that. I can go back. So for responsiveness of the site is just a very simple one, but of course it's responsive on mobile. Yes, it's responsive on Mac OS. Yes, it's responsive on some of these devices. This is how it looks on Windows. So that's for responsiveness of the website. All right, so the first thing I'm going to do is actually to see if my accounts actually updates if I reload the website as a new user. It has been on 37 since I started the shoot. So let me just reload and see. Yes, so 38, it has gone to 38, and it has also updated my time. So this all proves that my backend is actually working properly. My API calls are actually working. API is working. It's making calls to the Lambda function, and Lambda is actually checking DynamoDB. The table is not corrupt, so it's getting data from there and updating it properly. And requests are coming forth. So this is like a 200 response. So this is actually working properly. And then the next thing I'm going to do is just to go to my code and probably just check my CI/CD deployment once. Okay, so let me probably update my documentation and then push to Git and see. This is the Terraform configuration, and this is my documentation. So for my documentation, I'm just going to do a very small thing. And just updates. Thanks. I'll commit that. Docs review. Okay, so I can go back to GitHub and see. Besides, all the documents, my scripts, my configurations are on GitHub. You can always go there to check it out. So my docs review is already running. So this is going to be the Lambda function code test. It's going to test if my Lambda function code is actually working properly. And as you can see, it's a very small and fast, this process is running. So it's successful actually. Okay, here to show that. Yes, so that's successful. And now my deployment is going to run. So my deployments are running is workflow is actually based on the success of visitor count Lambda. If that one doesn't run or it fails, my deployment doesn't go through. Okay, so that has actually gone through. So if that is successful, like I can explain earlier, then my Cypress end-to-end test can work. So this test is just to look at the page itself and see if those things I want to be there are actually there, if to see if the count is actually increasing, if the visitor counts it's not zero, and some of probably images and all that, to just show that they are all there and running. So that is what my Cypress workflow actually does. Okay, so the test is actually successful as well. For Cypress, test is successful. Okay. Yes. So I'm just going to also run it locally and just see. Of course, it's the same thing, but that was okay. There's a mistake now. Okay, so Cypress is just going to check part of my resume page and see that everything is doing fine and working, all things I want to appear. So yes, it's doing the test already. So everything is actually fine. As you can see, it contains my image section. These are the few things. There are many other things to test for. These are the basic I'm just testing for. So non-zero counts, images are appearing. So everything is actually fine. So I'm okay with this, and I'm okay with this. I'm okay with this. Okay, so I'm just going to close this now. So some other thing to check is to see if my responses are being cached by CloudFront. So I'm just going to look at my developer tools, F12. Yes, so this is F12, my developer tool. This is, okay, let me reload the page and see. So at the moment, my responses are showing that 301, 304, and then responses are coming from, okay, so Scache, it is hit from CloudFront. This actually means that CloudFront is actually caching my response. So this is hit. If it's a CloudFront mix, it means the response is coming from the origin. All right, that means it's going back to fetch the new content. And of course, LHR, my content is being delivered from a server, CloudFront server in London, LHR. So if I should reload, let's see, it's still CloudFront hit because it's coming from the same server. So, but let me see and check if I can use a VPN and so to show that I'm actually accessing the website from a different region. Let me. So Scache missed from CloudFront. So this is, it's going back because it's a new region. It has not been cached in that region. So the response had to go back to the origin to fetch it. CloudFront had to go back to the origin to fetch it, which is the get method. And of course, that has demonstrated that CloudFront is actually working and caching contents. And it's caching contents, yes. And I can also demonstrate that through the command line as well. Okay, so this is the response. Again, time is showing content disposition inline. All right, so server is also Amazon. It's a hit from CloudFront, meaning is CloudFront is caching content and also coming from London. And let me just quickly show HTTP redirection, that this website is meant to actually redirect, CloudFront is meant to redirect content or traffic from HTTP to HTTPS. Yes. All right, so look at it. Content is alive. Scache redirect from CloudFront. So this redirection is actually happening from CloudFront and not from the origin, meaning the origin has nothing to do with it. It is CloudFront that is redirecting HTTP request to HTTPS, and of course that is also demonstrated through the browser as well. If I say HTTP, is going to redirect that to HTTPS, which is going to go back to the normal website. So that's the show of HTTP redirection to HTTPS. All right. Just to demonstrate how the site handles versioning, this is how it currently looks like. Now what I'm going to do is just to make a little change to my HTML documents and see if my new request is going to come from my origin instead of CloudFront, because if there's a change to the website, the new request to the website, get request, should actually go to origin so that it can fetch a new content and also displace the old one. All right, so I'm going to do that now by going to my code base to push a new update. So I've done a little change here to my documentation, but that's not what I'm going to upload. So I have a new site here. This is the one that is currently loading now, but I have another one. Okay, this is the one that is currently up. I have another one here with a little change that has a toggle feature between light and dark background. Okay, this is it. So what I'm going to just do is to bring that one in there. Let me rename this one. To invalidate that. So I'm just going to copy. Okay. All right, so I've copied the new one into my Terraform directory because it's actually meant to copy it from there. So I can now push this onto main now. Versioning. So let me see how it goes. So at the moment, I still have this. So my content is still the same because it has not updated. Go back to my actions and see what's happening. Okay, so my workflow is running. Once it finishes running, I'm going to check the site and see if there's any updates. So before that, let me just go back to this place and show that my site is still coming from the cache F12. The request is coming from cache. Okay. Oh, cache means actually probably the update is happening already, but let me, oh, not yet. Well, let me just allow this finish. Okay, so Terraform has actually showed that it's changing the site. Look at that. Speaking and updates to it. So these are the things. So it's actually done now. Yeah, so my actions are finished running. Cypress test is running, of course, just to show that some other things that I'm testing are really available on the site. But that's not my focus. My focus is the new website. Let's go back here and see. First, get out of this page. All right, so the update is done already. So we have a toggle mode. So this is a new one. So that is why the get request is actually going back to the origin. So we can see this toggle feature is now actually in the former one. So I now have it in my new updates. So that is how the website actually handles versioning. So going back again to F12, I can just look at the requests to the developer tools. All right, so it's a hit because I've requested it, it has cached it, and my reload just show that this is the new content that CloudFront has cached. So that is working. I move on to the next picture. All right, so now I'm just going to show how alerts are actually handled by the website. And what I'm going to do, I have a Lambda, I'm going to cause an API error. I'm going to cause an API error and see if there could be an alert, and that will also show how new content how the website actually handles new contents that are pushed to the website. So I have an error test here, and this for my Lambda function. This is the visitor counter Lambda function. This, yes. So what I'm just going to do, or what I've done, is just to cause a little error here. So I've raised different exceptions here that will cause an error. So what I'm just going to do is use the error tests, the error lambda scripts, and show if my website can actually handle errors. So I'm just going to edit this back. This is the normal one that is giving me response 6. I'll just name it original lambda. So name this one the error. All right, so I have a new visitor counter which is going to show an error. I'm going to push this error test. Push this to GitHub, to my repo, and that is going to start Sable commit. Going to my repository. I'm just going to pause for that to run. Oh, it has started running already. So let me just leave that. Again, the code is going to run. The Lambda code is going to run. And of course, it might not fail here because of the type of error I'm causing. So it's going to that will make the infrastructure itself get an update on AWS so that my test can actually be achieved. If not, if it fails, I won't be able to achieve my test. Taking a bit of a time here. Okay, I think that should be a success. So Terraform has actually changed the Lambda function, and of course Cypress test is going to run. So even without me doing anything, because Cypress is going to call the API automatically, because I've set the alert to actually alarm within 1 minute of having that type of error. So if you go on AWS, definitely my AWS. I'm going to pause so that I can sign into my AWS account. All right, so I'm in my CloudWatch. I'm in my AWS account at the moment. So if I start refreshing, at the moment I have 3 alarms, all alarms. So I have 3 alarms: the Lambda alarm, my API alarm, of course my billing alarm. So let me just try and come back to at the moment there's no alarm. So if I try making calls to the website now, let's just say 2 calls or 3, and wait a few moments and see if there's an alarm. All right, you see, so my Lambda is already alarming to show that there's an issue, and of course automatically there should be a message to my Slack workspace. Okay, it has not arrived. Exactly, so my error has arrived. Okay, so Slack is actually notifying me. So, and if I check PagerDuty and see 1 triggered, so 1 has been triggered, an incident has been triggered, and if you check the time, it's going to be just now that it got triggered. So just now at 11:53, almost the same time when the API received it. So, and of course that's the time now, 11:54 now, 1 minute after. All right, so it means my alerts are actually working, so I can get notifications to PagerDuty so that my teams can handle it. Those on shifts can actually handle the downtime and if there's any issue, and of course I can get it on Slack as well. So that shows my website is actually handling errors properly. So the next thing I would like to do is actually I'm going to test my manage rules and see if my AWS WAF is actually working properly, and see if it's actually stopping requests or not. So that's what I'm going to demonstrate now. So for that, I have a server that I've actually launched, an AWS. Let me just go through that. An EC2 running on Ubuntu OS. And I'm just going to SSH into that and use Apache Benchmark to to load my API. So I'm going to connect to this instance using instance connect. Okay. Okay, so I'm already in the instance now. So I'm going to, if you look at properly, let me show you my main, the roles, the manage roles for my AWS WAF. So this is my WAF. If you check it properly, let me just increase this a little. Yes. So for the rates based, for the rate limit rule, I've made it 350. This 350 means that an aggregate key type is IP, meaning a single user cannot make 350 calls to my API, to my website, of course, to my API within 5 minutes. So 350 is the limit. So if I just make a call, of course, I've made a call before. All right, so let me use Apache benchmark. So to make 10 calls at the same time, three concurrency, meaning they are going to happen 3 times. So let me just do that. So this is the results. They are all serving. The waiting time is 3 milliseconds. Maximum waiting time is 14 milliseconds. Connection is 8, and it's serving properly. Okay, the server is this coming from my web server, and then TLS, so it's properly handling security. All right, so this is just to show that a normal request is going to go through, but let's assume I am going to increase this to maybe 500. Yes, so 500 concurrency, let me say 10. Yeah, look at that. Field request, completed request is 500. So this request, okay, so let me also do probably 1000. Okay, 1500 and just 100. Yeah, so look at this now. Because I've increased the rates to 1500, so many of my requests have actually failed. If you look at this now, non-2SS error. All right, so 200 is actually okay request. So non-2SS error, so 1300, meaning 1328 requests failed out of 1500 that I sent. Where's the 15? Yes, so completed request is 15, meaning there's no issue with the server. Is actually receiving the request, is going through, but then it means my WAF, web application firewall, is actually blocking them. All right, so that's why 1328 has actually failed out of 1005. So maybe 150 or 170 requests were actually served. So that's actually how I test that. And if I'm just going to use a regular and just see, and let's return the error on the screen, the status. Let's say we are just going to do 40 requests, 43. Okay, I know what's happening because it's the same IP, so it's actually blocking them. So let's just try, because I've run 500, so it's actually blocking the same IP. That's what WAF is doing. Let's just be very lenient and run 4 requests, 43. It's going to take a few minutes for me to be able to run a successful request on this. Still 43 error. Okay, I'm just going to probably pause for a minute. Okay, so it's still giving me 43, meaning I've run too many requests with this IP. So what I'm going to do, I'm just going to exit this one. I'll probably run it on my home PC. Yeah, as you can see, 200, meaning errors. My requests are actually going through, and I'm receiving responses. So that is to show that my WAF is actually working properly. And next, I'm just going to do like a cross-site scripting request, and I'm going to enter the request. I already have it here. I'm going to enter it on my browser and just see what happens. So if you can see, my website is actually live. Yes, so but let me enter a cross-site scripting requests and see. All right, so access is actually denied. So we can't connect to the server for this app is for app or website at this time. There might be too much traffic, of course, because it's actually a bad request. So my website is actually blocking it. So that is happening because WAF is actually doing that. WAF is the one blocking it. And if I also do the same through the command line, it's going to expressly show that WAF is blocking the requests. Okay, so request blocked. Request blocked. Why? Because it's a cross site scripting script or request, and it means that my website is actually working properly. And next, I'll just try a SQL injection and see if my site is actually protected from a SQL injection attack, and go back to the browser and enter it. So this is my requests. Let me see. Again, access is also denied. My website is also blocking that. So really, my AWS WAF is actually working properly. And if I go to the console, I can see some of all this, some of the analysis done here. Let me go to CloudFront and see. Just analyze the traffic, and there's a better way to also do it. I can also export these streams, these logs to S3, and then I use probably Athena to search them for a better analysis. But I'm not doing that at the moment. So, but I have some of these logs exported to CloudWatch logs. So see, these are some of the requests, and if I can do it on a bigger screen, I don't know if it's possible. Okay, so I have all requests 4,000, 4K plus, allowed requests 1,700, a whopping 2,000, 2.3K requests have been blocked. If it's going to analyze them, allowed, blocked. This is between 1806 and 22. So top types attack, you can see the top one was SSX, cross-site scripting, and the countries of request: United States, United Kingdom. Okay, so all requests 135 that have been blocked. So sample coming from robots or from bots. Non-bots was 77% on verified accounts or verified requests and all that. So this is just what the security page looks like, and of course there's going to be more actions to this or insights if they are exported to S3 and then for analysis. So these are just some of the things I wanted to test and showcase with my project. And of course everything is working for now, and I'm going to be stopping my analysis here and waiting for perhaps comments and suggestions on how to make this project better. I know a lot of people have insight into this, and if you have insight on probably how to make this project better, services, and how to probably better protect the website. I think I just need to talk about some of the challenges I actually faced. I faced a lot of challenge actually building this project. Let me just quickly go back to the architecture diagram. I think the very first I faced, not so much with building the front end, because I'm not so much of the front end, but writing actually the Lambda codes to forward my messages to Slack and PagerDuty it took me a bit of time, and also writing the Lambda function that actually executes the count also took me some time. And one other thing was the fact that once I make a request, and most of the time the browser just blocks the request, so course setting, I know, was also a place I actually also spent a little time in actually debugging. So these were some of the challenges I actually faced. Another was AWS managed roles. It gave me a lot of time. So what I did was, comment out many of the roles and just test them one after the other. First was my rate limiting role, which I tested and it worked. Then I proceeded to cross-site scripting, and lastly was common vulnerabilities. So, but what I learned from this was the fact that it's good to actually check documentation, in the sense that the documentation showed me that I was trying to override some of the default rules of AWS, and that was why I was having issue with the rules that we were not running. So what I now did at the end of the day was to just use override action none. So it means just for it to use AWS default settings, and where necessary block. Here I actually override the default setting, and also this, and like that. So I had a bit of challenge with the WAF, but I was happy that I was able to actually overcome it at the end of the day. And other different challenges, and the good part is I have documented some of the challenges in my blog dev.to. Yes. So I've documented them. If you go to my dashboard, yes, so I'm here to actually post this publicly, but if you look at it, each of the stage or each of the section, I have documented my challenge. Of course, look at it now. Course setting was my major challenge. Browsers were blocking my request to S3 due to incorrect course headers. I checked the AWS documentation. So each of the sections I've actually added my challenges that I faced. I spent time writing the Lambda code. My function needed a parameter to recognize the unique visitors, which I also explained earlier. So I would like if you can go through this and probably also comment, and like I said earlier, also mention, and if there's any suggestions you have for me to improve. And of course, this is a screenshot of the alerts coming to my phone, PagerDuty, meaning that my backends are actually working properly. So thank you once again, and then I hope to see you in another video through another project. Thank you.